All right, 11:30, time to kick off. So today's presentation is going to be about distributed domain-driven design, really domain-driven design. And, sort of the motivation for that is that I think the design is going to help us communicate better, communicate to ourselves, other programmers, the people leveraging the requirements, the actual users, which will help us meet better requirements. And then long term, obviously there's a cost to design, but long term, I think it will help us with our ability to be able to add new features. And at any time, if you have any questions, just chime in. I won't be able to read the chat, but if you just want to, use your mic and chime in. So software development really is all about communication. And really a lot of times why software projects fail is because we build something that the user, it's not really what the user wanted. So the users are typically domain experts. So they live in their domain, they have a problem, and they describe their problem to us. And, when they describe the problem, obviously they have all the domain knowledge. So they bring all that background. And so, this sort of illustration here, how the customer explains it, that's really how we as developer hear it. So then, you have another set of translation. You might have a project leader or somebody who actually talks to the customer who's not a developer. So they have yet another translation level. Then analysts designing it, another translation level. The way we actually implement what we think they want, and then, applying patches, and, in this case, what the customer really wanted, was this tree swing with just a tire. But it's really hard to do that. And so getting the requirements from the customers and actually implementing what they want is one of the big things, one of the big costs of software development. But then the other cost is maintenance. And, maintenance, so once we've built our first release and, put that out there, we're really in maintenance mode. But maintenance doesn't only mean, it's not something static. It doesn't mean we're just going to fix bugs and, watch the program run. If our project is successful, people are going to want more features. So we're going to have to add more and more features over time. And so the estimation is that, sort of 40 to 80%, usually about 60% of the total cost of software over the life cycle of the software is spent on maintenance. And that's, enhancements and new features and fixing bugs. Now, maintenance phase is really very similar to sort of greenfield building software the first time, but the additional complexity comes in from having to understand what's already there and figuring out exactly in what area to add the new features. So that's approximated to be 30% of the whole maintenance effort. It's just understanding what's there already and trying to figure out where to extend the current design to add something new. And, there was a quote, and I'm not sure who's it attributed to, but, old software becomes obsolete, but old hardware becomes obsolete, but old software goes into production every night. And, for some of you, this might have been a little early, but Y2K, we've had this problem and we switched over to year 2000 because of the, people modeling the date as just 2 years. And there's been a ton of software around. So like when people first wrote that software, in the 70s, 80s, They're like, oh, it's going to be replaced by the time, you know, that problem ever hits. We don't have to worry about it. But as many COBOL programmers can tell you, that was not the case. That software was still around. So software maintenance is a big deal. When we write software, and, you know, like if you're writing in Java, Java actually has an annotation at author. You know, we are really the author of software. Like, we choose the abstractions, we choose the words, the nouns, the verbs that go along with it. But like when you look at this, and this is what I'm trying to say in this slide, like the user, the domain user, they use natural language to describe the project that they're doing, to describe their problem. So that language is inherently imprecise. But it also has a lot of domain jargon in it that means something to that user, but might not mean the same thing to us. So at the bottom level, the computer understands ones and zeros. So like once we write the program gets translated and the machine executes those ones and zeros binary instructions. But the software that we use to translate the requirements from natural language into something that the computer understands is really written for software developers, and software developers having to maintain this software. The user typically is never going to look directly at our code, but other programmers will. Other programmers in the future that are going to try to add new features, and that programmer might very well be us, like 6 months from now, 1 year from now. And I don't know if you've ever had this experience, but you know, sometimes when you look at your code 6 months later or a year later, you know, you're like, whoa, what was I trying to do here? And it's going to take you all that time to figure it out. If we just take the time initially to make that code as understandable and as readable as possible, you know, then that task becomes a lot easier. And, you know, we'll be able to just keep going at the same pace, adding new features release after release. So domain-driven design, you know, what's a domain and what's a domain model? So when we talk about domain, you know, we're really talking about a specific area of knowledge. So it's, you know, it could be sort of a problem domain that your customer is trying to solve. That's really all we're talking about when we're talking about domain. Now, when we translate that domain into an abstraction, into a model, we create a domain model. And when you look at George Box's quote here, all models are wrong, but some are useful. Think about it, like the model is an abstraction of the real world. It's not the real thing. It's more like a blueprint. And we choose like what's important in the model, what we want to keep, and what we want to exclude. And we also choose in our abstractions, like the words to implement, the verbs, the nouns. We basically develop a domain language. Now, you know, like think about for a domain model, like if you were to write a car simulation, you know, what's the simulation? What's the purpose of the simulation? Are you trying to do a driving simulation, in which case, you know, you have a steering wheel and maybe some accelerator, brake, and that's good enough? Or is your simulation trying to figure out what the fuel efficiency of the car is? In which case, you know, you got to figure out the aerodynamics, you got to figure out what's in the engine, you know, basically a whole different abstractions, but they're both car abstractions. But it really depends on what you want to use that model for, and it's obviously not a real car. Now, as programmers, you know, a lot of times we translate things, and, you know, instead of using nouns that are in the problem domain, we sort of translate them into things that we can understand, and then, you know, put some programming specific things in there. So like in this picture here, you know, the door is the indoor session initializer, or the TV might be the entertainment provider singleton. And as a programmer, when you see this stuff, you know, it's like, okay, I know what a singleton is. I know what a delegate is. I know what a controller is. But like these things have nothing, like when a domain expert looks at that and you talk about the entertainment provider singleton, they're not going to know what you're talking about. So at any time, you have to translate from what the software developer is talking about to what the domain expert is talking about. And then when the domain expert talks about something and they're talking about a TV, you got to remember, oh, in my domain, this is really an entertainment provider singleton. So you got to, you know, translate back and forth, and maybe, you know, some of the concepts get lost in translation. So Alberto Brandolini, he's a big guy in domain-driven design, you know, has this quote: "It is not the domain expert's knowledge that goes to production. It is the assumption of the developers." So like, you know, the domain experts, they know what they need to do. But like, you know, we as developers actually implement what we think they want to do. So we want to keep that gap. I mean, hopefully no gap. You know, we want to work together with the domain experts. And so when you look at domain-driven design, you know, sort of the first, they call it a strategic concept. So they have strategic concepts and tactical concepts. The first strategic concept is the concept of ubiquitous language. And what they mean by ubiquitous language is that basically everybody uses the same terms. You know, we speak the same language. So like whatever the domain experts call something, that's what we want to use in our software to represent that concept, so that there's no need to translate from computer science to domain experts and vice versa. When they look sort of at the high level of the code, they can see the concepts that they're looking for. And they can also see like the things that are important to them, the things that they're trying to do. They see those in interfaces in the method names also. So, you know, later on, we'll talk about this concept of intention revealing interfaces. So rather than just having a bunch of getters and setters and doing stuff, you explain why you're doing all this stuff and, you know, have a name for it. And that name should match what the domain expert is using. And so, you know, as we have all these different definitions, we're going to need like a glossary of terms and their definition so that we're all using the same things with the same meaning. And obviously this is going to be an iterative process, and domain-driven design is really, you know, part of agile. Like some people say, oh, design, you know, in agile we don't need design, but that's really not the truth. Whether you explicitly make a design or, you know, whatever you develop, that's the design. You will always have some kind of design. It's just that we're trying to make the design match what the domain experts think about and work closely together, which is another sort of thing you want to do in agile programming, right? Work with the domain experts to come up with a solution. And so the ubiquitous language is everybody really speaking the same language, using the same terms, so that we can understand what we're talking about. And especially in the application code, you know, we don't need a translation level. So another concept, and this is, you know, when you think about large software development projects, you know, think like an Amazon. Like, you know, once upon a time, the Amazon page was like a large monolith. And that monolith, you know, was all in one application, and everything had to be released together. And, you know, there was all this different functionality, just kept growing and growing. And, you know, eventually, like when you start looking at it, you know, the domain, your overall problem domain, you can really divide it into subdomains, different problem spaces. And within those subdomains, like here in the sales context versus support context, we might have similar terms, but they might have slightly different meanings, or they might carry slightly different data. So instead of trying to come up with a globally unique model that meets everybody's needs, so like you put everything you ever need to know about a customer, in the customer class, having these bounded contexts basically divides the whole domain up in subdomains. And the solution is the bounded context. And within a bounded context, you have the ubiquitous language that stays stable. And so in another bounded context, like in this example here, we have customer and customer. But in the sales context, the customer might have an address. They might have a time when they were last contacted. They might have information about likelihood of sale. Well, I don't need that in the support context. I still have a customer, but in support, I might have, what kind of support level do they have? Are they bronze, silver, or gold? So I know how fast I got to do something. What's their preferred contact method to get back, when something's resolved? So it's different information needs, same concept, customer, but different information needs used in slightly different ways. And so the bounded context really gives me, within a bounded context, the concept of a customer is what's needed for that subdomain and nothing else. So I can focus on, for that domain, what the domain experts need to do with a customer. So if you have a very, very big problem, what are some heuristics to figure out what the subdomains are? Well, some of it is like, the organizational alignment. So, sales is going to be in a different department from support. And so I might have two different teams that are working on these things. And so clearly, if I make those things their own microservices, their own bounded context, and a lot of times one bounded context is realized as one, sometimes more than one microservice. So that makes sense. But it might also be, you realize that, in this concept, like I need this type of information here, but I need slightly different set of information here. Well, maybe these are really two different bounded contexts. And so I want to move these things apart. Or, you have some sort of workflow that indicates, well, first I need to do this, then I need to do this. And, the product of the first part is going to be the input to the next part. But other than that, they might not have a lot of relationships. So those are all sort of heuristics as to getting into bounded context. So another concept is then a context map. So between the bounded contexts, if you're building a big system, they're going to have to communicate. And that's really what the context maps are all about. They tell us about the relationships between the different bounded contexts. And the U and D in this diagram are sort of the upstream, downstream dependencies. So upstream is like a producer, downstream is the receiver of that information. And then DDD, I'm not going to go into all of the details there, has different ways you can do the integration between two different bounded contexts. For example, here, one of them we have a partnership. So expense tracking and our banking, they have a partnership relation. So they manage their model basically together and the interface between their model. So they do joint management. You have to have integration tests, joint release schedule. If you have a partnership, you got to release these things at the same time if you're changing the interface between those two things. Sometimes you might have a bounded context that has part of it that can be reused in another bounded context. In that case, you might have a shared, what's known as a shared kernel. So you have a sharing of the model subset. Sometimes you might have an open host service. So you have some sort of published language like a REST server or something. And you know how to invoke that, maybe how to version it over time. So those are all some the examples of how you might integrate. Now the ACL you see in the slide here is actually a anti-corruption layer. And basically what an anti-corruption layer does is, like, in this case, I have my online banking services. Their model, has some of the pieces I need, but maybe, they're put together in different concepts. I'm going to have to build, like, a new object out of it. They might give me 2 different objects. I just need one. So I have this anti-corruption layer. So no matter what they have in their model, I can translate it into the terms that are optimal for my model and for my bounded context. So that's what context maps are all about. Like, for the bigger pieces, they tell us how they're put together and, what the interfaces are. So, thinking in terms of the bounded context and the context map, I mean, that's really the strategic thinking in the large. And that's not always an easy problem, trying to figure out how to best split up your overall domain into these subdomains into the bounded contexts. But those are the strategic patterns that we can use. And obviously, if you have a big project, those are very important for the success of the overall project. But domain-driven design also offers some smaller patterns. And this is really a pattern language. If you've heard of the Gang of 4 software patterns, a lot of this is very similar, but sort of reduced to core patterns that they think are applicable in sort of most domains. So the first core pattern, the tactical pattern, is an entity. So the thing about an entity, when you model an entity has to have a unique identifier. So in this case, we have a customer that has an ID. An entity can also have mutable attributes. So for an entity, I have an ID, and then, like, first name, last name. I can change my name. I can have a list of addresses I can move. So I'm going to update an address. I have, in this case, for this particular domain, it's probably like a sales domain. It's important to know what interactions I've had with my customer. Like, when were they last contacted, or what did they last buy? So I have an interaction history. Obviously, that can be updated. So entities have a unique identifier, mutable attributes. And then the important thing about domain-driven design is we design, and this is a lot like object-oriented programming. We design objects that have state, so those are the attributes, but they also have rich behavior. And the behavior, these methods that they have, like get known interests or get territory, they reflect what the domain experts typically do with those type of objects. So, like, for a customer, they want to know, what are their interests? And the interests might be computed from the list of past interactions that they've had. Or, maybe we use some machine learning and figure out what similar customers, have done. So, there could be a lot of implementation behind it, but we're all putting it in the customer because that's where we're expecting that information to be. That's the thing we want to know about for, like, these known interests. Our sales area might be divided into different territories, and those territories are controlled by the addresses, or whether somebody is a commercial versus private customer. So all that logic can live inside the customer. So these entities are not just, sort of contain state. They also contain very rich behavior, and with what they call interface revealing messages. So, like, the names of the methods that you're using are the names of these operations that the domain experts would use. And a entity can also, reference other entities, or what we're going to look at next, value objects. So a value object, a little bit different from an entity in that it does not have a unique identifier. It's also immutable. So like once I create a value object, I can't change its state. I'd have to like create a whole new object with, you know, something being changed. And the equality typically, you know, for the entity, the equality is by the ID. For value objects, the equality is controlled by the attributes. So if something has the same attributes, you know, depending on what you need in your domain, maybe it's only a subset of the attributes, that would mean equality. But these things are still rich in behavior. So value objects and entities have a lot of methods that are needed to maybe validate these things or you know, do something that the domain typically needs to do with these things. And so again, we want to use intention revealing names for the concepts using the ubiquitous language to model these value objects. And a value object, you know, some other examples might be money, where you have a unit of currency, you know, maybe dollars, and then the actual amount. And, you know, sometimes depending on your domain, something might be modeled as an entity, or it might be modeled as a value object. An example of that might be, you know, if you think about an airplane seat, even though, you know, nobody's traveling right now, but like in the future when we can again, think of an airplane seat. If you're flying on like United or Delta, you're going to have an assigned seat. So you're going to have a seat number, you know, row and, you know, a letter behind it. So that's a unique identifier for that seat on that flight. Whereas if you're flying with Southwest, so we would model that seat as an entity. But if you're flying with Southwest, they're just selling you a seat, right? You don't have assigned seating. You have boarding priorities or something. But really, like whatever seat you pick, that's where you're going to sit in. So maybe in that context, a seat would be modeled as a value object. So putting these things together then, we can build aggregates. And really what aggregates are sort of these combined entities. At the root of an aggregate, the aggregate root, you always have an entity. And it's sort of a collection of domain objects that are bound to that entity. And you always, and the only way you can access things inside of that boundary is through the root. So you can enforce invariance. And basically, if you do updates, that aggregate really shows the transaction boundary. So like when you do an update, you're guaranteed that everything within that transaction boundary, it meets the invariance, and you know, it sort of gets updated at the same time, and it can have different relationships. And when I delete the aggregate root, I will also delete all of the value objects and entities that are associated with it. So, you know, basically giving us, you know, if you will, like transactions across a set of objects. Now, in all of this, you know, we want to make sure that the behavior typically lives in either the entity or the value object that it's associated with. But sometimes, you know, there's behavior, things that we need to do that really doesn't fit within an entity or a value object, or it might involve multiple entities and value or value objects. So in that case, we can model things as a domain service, and it's really like a small pieces of functionality. It's always stateless, so I can't like embed any entities or value objects in it. It's always stateless, and you know, serves like a specific purpose that goes across the entities. Now, if you build too many services, you know, if you like put everything in these services, then you get to the problem of building an anemic domain model. So on the left-hand side, and I mean, I think we've probably all seen things like that. You have at the top, these S's are services, and they're pretty hefty because that's where all the behavior, the functionality lives. And then those services, in this model would manipulate or use entities. And everything has to be an entity because we're using these DAOs to put stuff into the database. And so we need unique identifiers in the entities to store stuff in the database. But really, there's no domain logic, if you will, in the entities. They just contain a bunch of data that gets translated into DAOs that gets persisted. And really, most of the logic is going to be in the services. So that would be creating an anemic domain model. We don't want to create that many domain services and put the functionality in there. We want to use the case on the right-hand side where we have the domain services, but they're very, very thin. Only specific cases where the functionality doesn't fit within the domain object. And all the functionality, the rich behavior, really lives in the domain objects. And here, we sort of model like 3 aggregates. And the aggregates, always have the entity root. And then, the one on the left has like several value objects that are associated with it. And that whole thing gets persisted by using a repository. And we'll talk about that in a second. So the repository pattern will persist the whole aggregate into the persistence layer. So it's very different in that the domain logic, most of the domain logic is associated with the domain objects, not with services. So then, another pattern, and this is basically from the Gang of Four, is this factory pattern. How do you create one of these entities or aggregate roots or value objects, if they're complex enough? You can have these factories that, basically, typically you have like an interface, and then you can have concrete implementations of how you can actually instantiate different objects. And like for one aggregate root, you would have a factory for that aggregate root, like an interface. And then, maybe have one or more concrete implementation of how you actually want to do that. Do you have to access a database? Do you have to go out to the web to do some lookup, from a file? You can hide all that behind the factory that's going to create these things. So a factory is basically like, if you've heard the term CRUD, create, read, update, and delete for database functions. A factory would be like the C, the create in CRUD. Then we also, and we saw this earlier, have this concept of repositories. And so the repositories, that's really the read, update, delete. Again, for repository, we use an interface. And typically for the repository, we want to make it look like an in-memory collection. So I can add an object, I can delete an object. I might have different methods to find something according to what the domain logic needs. But it's really sort of like an in-memory collection would be the interface for it. And then the actual implementation could be like, I could store something in memory. I could store it on the file system. I might have a caching layer. I can do database storage. Maybe when I load something, I can do lazy loading to where, if I load an aggregate, I load the root first, and only if somebody accesses its child members at that point, I would actually pull those in. But that's all hidden behind the repository facade, if you will. So factories and repositories, and sometimes, people just sort of throw these together and make the repository also do the create part. So we talked about domain services. So that's part of the domain model, functionality that doesn't really fit anywhere. So the domain model by itself, just describes your problem domain and solves business cases in your problem domain. But the actual use cases interacting with that problem domain will actually go through what they call in DDD an application service. So that's where we sort of expose the domain model to outside clients. And we can, like make a copy of things. We might transform things. The application service might sequence interacting with domain services, entities, repositories. In the application service, we might have the application workflow. So this would be where we store like session state. And basically how we do all the different use cases would be represented at a high level at the application service layer, but they don't contain any business logic. So they don't contain any state of the domain objects. That's strictly in the domain model. But like I said, they could hold workflow. So an example of this might be, I might have an application service that lends a book to a client. And that application service behind the scenes might retrieve the client from a repository. So I might need an ID or something to find the client. The application service might validate the permissions. So like all the security stuff, all these extra things that are not part of the domain model, would be handled at the application service. For example, authorization, authentication. And then with the lend to book client, it could call a domain service to actually lend the book to the client in the domain model. But it sort of ties all these things together. And it includes all the pieces, that are sort of unique to the application, whereas the domain model is pure in that it doesn't have any, it doesn't know what framework it's running on. It doesn't really need to know, what database it works with, what its UI looks like. It just focuses on the business domain and the business logic and represents that in the words that the domain experts use. And, you've all heard of probably everybody's familiar with a layered architecture. There's also a different way of looking at architecture, and it's called the hexagonal architecture, sometimes also known as an onion architecture. So rather than looking at things in the different layers that we're used to, we might have a UI layer, business layer, persistence layer. We sort of flip the focus a little bit, and at the center of everything that we're doing is the domain model. So that is where the business logic lives. The domain model, that's the objects and the entities, the value objects and the entities. We have domain services that work with potentially different entities and objects. And then the thing that then actually will talk to the outside and implements our use cases is the application services. So the application services, when a request comes in, they translate that into the domain model or invoke the right sequence in the domain model. Now, the other thing about hexagonal architecture, they have this concept of ports and adapters. So when you look on the inside, I don't know if you can read this depending on your screen, you have like different ports. Like in this case, you have services, we have like a persistent port, we have a search port, we have a notification port. All these things are just interfaces. So they're interfaces to something. And, like at the application layer, I don't know exactly what I'm going to interface with. I just know, the shape of the interface. Then on the outside so I have ports on the inside, adapters on the outside. Those adapters actually implement the interface. So if I have like a persistence layer, You know, like behind the scenes, I might use like object relational mapping. So that would be the implementation of the interface. I'd be using ORM to actually do the persistence. You know, like I don't know what kind of notifications. I just call the notifications interface. Behind the scenes, you know, that might go out as a text message. It might go out as an email. I don't know. I can publish events. And so when you look at, you know, the outside of the hexagonal architecture, you have these adapters, and we distinguish on the left-hand side. So this is traditionally where you might find your user interface or like a command line interface. Those are the primary driving adapters. So that's where all the stimulus, if you will, comes in to, you know, cause something inside of our domain to execute. And, you know, we might have like a web server that talks via REST, or, you know, a CLI where we can do console commands. But all of these then cause something. So they cause something in the application services. And then the application services work with the domain services and domain model to fulfill what needs to be done. And, you know, if something needs to be persisted or read from a database, they will access these ports to then move to the adapters and read in that information. And so, you know, like on the Raven team, we're using a framework called Akka. And, you know, Akka basically has all these different modules, if you will. There's like Akka persistence, Akka sharding. A lot of that is really adapter implementations that help us, you know, focus on our domain. Like in the Akka world, an entity would typically be an actor. It's, you know, an independently running piece of code that executes on its own thread, only reacts to messages. And we build our domain around these concepts, but then like persistence and messaging notifications, you know, Akka provides infrastructure to do all that. So hexagonal architecture, you know, it's not part of DDD, but that's what a lot of people are using, you know, with DDD. But, you know, you could also use a layered architecture if that's already what you're used to. So in summary, and, you know, this is a lot of information in a very short amount of time. And I think, you know, until you sort of work your way through and actually try it out, you know, it's as much a communication activity as it is a learning activity. You know, it's very abstract. But if you start using it, you know, it's sort of day to day, before you actually write the code, take a step back, you know, talk to your domain experts, find out what they call things, and then represent the same things in code. This can be a wonderful way of building, you know, a very, very rich domain model that can be maintained a long time. But part of the maintenance cost, of course, is going to be refactoring. Because when you first start a project, that's really the time when you know least about what needs to be done. And, you know, like as software developers, we love to use new frameworks and new technologies and new libraries. So there's all this technical complexity that has nothing to do with the domain complexity. And, you know, only sort of, and that's really the key behind Agile, is that we have these fast iterations, right? I mean, we used to do waterfall. We have the big design up front, and then, you know, you figure out everything. But when you do the big design up front, at that point, you don't really know what's needed and how to implement it. So as we're doing these small agile iterations, you know, we're doing our sprints. During that time, like every sprint, we're going to know more than we did the sprint before. Plus, at the end of each sprint, or, you know, our release, we show it to the customer. So we get feedback. It's like, oh yeah, I like this. No, this was not quite what I thought of. So we get smarter about the problem domain and how to implement all this stuff. But while we're doing it, we try to translate all the concepts that we hear from the domain experts into this ubiquitous language to where, when they talk about a concept, we use the same term to implement that concept in our code. And then, if they need to do operations on that concept, we call them the same thing that they're calling on the outside. And, the patterns we have to do that are the strategic patterns, where first of all, you figure out, can all this work? Like, what's the subdomain where the ubiquitous language basically is stable? Like within a certain context, I can say, here's the meaning of something. It might not be the same meaning in a different context, but within a bounded context, I have the ubiquitous language. I have specific meaning. Between bounded contexts, then I have the context maps that tells me how these things work together and what information they need to exchange. But then actually implementing DDD, I have these tactical patterns. An entity with an ID and mutable state, value objects, attributes, and immutable states, but both entity and value objects with a lot of domain functionality. The business functionality, the business logic is implemented primarily in entities and value objects. And then I can combine those into aggregates. And within an aggregate, I might have multiple entities and value objects, but the only way I can access any of them is through the root aggregate, which is an entity that I first need to access. So I don't have access to other objects within the aggregate, only through the root entity. And that guarantees me a persistence, a transactional boundary to where I can meet all the business invariants. No code can go in and change something. I can control like how changes are made as the aggregate root and make sure that they meet all the business invariants. So then creating things, I have the factory. If I have something that I need to retrieve or delete, I can go through the repository pattern. And then for things that don't really fit into the entity or value objects, I have these thin domain services. Remember, like we don't want the anemic domain. We want most of the functionality in entities and value objects. Things that go across, we might have in the domain service. And then the application service is sort of the outside facing thing that interacts with the clients, that might store session state, that worries about security, authentication, authorization, how something actually gets persisted. And then the hexagonal architecture is just yet another way of looking at all these things together and making them work to solve some kind of domain problem. Intention revealing, like one example that stuck out to me was, in one of the talks, somebody was talking about, intention revealing might be the difference between walk to the conference center. So that's the intention that I have. A lot of times, though, when we implement that in code, it comes across as, go half a mile straight on this road, then take a right, then take a left. So we break down every step. And if that's all I'm seeing, I don't know why you're doing that. So, I can see what you're doing. And remember, the computer understands ones and zeros. Under the hood, the walk to conference center probably uses those smaller primitives in terms of how to move around. But, from a business perspective, all I need to know is walk to the conference center versus how that's actually implemented. And so in our code, these intention revealing things, it's all about communication. Use the terms that the domain experts use and, use the objects and implementations, so the nouns and the verbs, to do that. So at this point, are there any questions? Everybody's been very quiet. It's a lot to take in. If this is the first time you've seen DDD, there's actually, whole conferences on this thing, several books. If you read people like Martin Fowler, who's sort of very famous, I think, to me, and doing pattern and object-oriented programming. He has a lot of articles about DDD. He was also a big guy in agile development. So it's really, for complex domains, complex problems, it's a good way of dealing with the complexity of the problem without introducing like all this extra complexity that's just happening in the implementation. So, think about the ubiquitous language. And so, really, like, I think the difference is like using DDD, instead of going from a requirement from a ticket directly into implementing that in code, you might, get the group together and talk about, okay, for this requirement, and this can be very informal. This might happen like after stand-up, or, we might have like a spike if it's a complicated thing to implement. We might want to look at different ways that, we can slice and dice the domain and put things together. But it's part of the agile process. But before we code, we actually talk. And we talk to make sure that when we implement that functionality, first of all, we all use the same terminology, so we're consistent across our code base. And we use the terms that are actually used to describe the problem by the domain experts, ideally working closely together with the domain experts. And then doing the implementation at every point, trying to make sure that the concepts, like with every use case that we solve, design becomes a little bit clearer, like we learn something new. So the question we then have to ask ourselves is the current design, are the concepts still crisp? Are they clear? Do I have the right operations in the right objects? Do I have the right objects? Do I have the right interaction? So at every time when we get a new use case, that's going to challenge our current domain model to see, we might have to introduce new concepts, or we might have to move things around. And that's where the refactoring comes in. And the only way we can do refactoring is if we have a good test base that tells us, after the refactoring, that everything is still working. So this is all part of the agile process overall. It's just making the design part a little bit more explicit and using that to communicate. All right, well, thanks for listening. Hopefully, this was interesting. I have a lot of resources. Eric Evans, that was the original book, Domain-Driven Design, in 2004. He also wrote like a much smaller condensed version in 2015 that sort of works with the book, but gives you new insights. Vaughn Vernon, he's written a lot about actually implementing domain-driven design. And, in his book, he sort of has an example he steps through. So, take a look. There's some other links here. One of the courses I took, for using ACA and using domain-driven design to build these, what they call reactive architectures, was from the Lightbend Academy. That was actually a good course, and I think with a little bit of background, that puts things in perspective. And these other resources are links to different places. So domain-driven design quickly is like a really condensed version. I was working on a project beforehand where we just kind of read that to give us enough start, and then use it all together. All right, well, thank you. That's all I got.
Thanks, Marcus.
Thanks. All right. Have a great rest of the day. See some of you at stand-up.